Hi viewers and welcome to the channel, and today we're answering a Patreon's question regarding RC tyres and how you would make them using a spreadsheet so they can be scaled up and down. So this tyre is made up of both a hub and a tyre, and they work together in a spreadsheet. So in here we can change, say, the axle radius, say 4, and come back. You can see that's changing, so we'll need to change also the hub radius to say 40, and we can change the hub width at 20 and the tyre height at 24, voids at 12, and when we come back that's all changed in there, and you can see we've got a different shaped tyre to what we had before. I'm going to be taking you through the basics of creating this and some of the gotchas you'll come across, so some of the errors that will occur, how you get around those errors. Certain formulas that we'll be entering may come up with a unit mismatch, how to get around that. So this is quite a long video, but there's quite a lot packed in there. So I hope you're enjoying these videos, and let's have a look how we will create this. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. So I'm in the part design. We'll create a body on the task, create a body and create a sketch. I'm going to place it along the XY plane and hit OK. I'm going to sketch above this red line here because we're going to be revolving around that, and I'm going to look at the profile of the wheel and use this line as symmetry, and we're going to be sketching and comparing as we go to have a look to see what that looks like and just add into that sketch as we go. So I'm going to use the polyline. We're going to start down here, so this is where the axle will go through, and we need a bit for reinforcement, so this here. We've got the auto constraints on, so you can see that we've got horizontal and vertical constraints automatically being added, so you can see them by the mouse pointer as we move. There it goes into vertical constraint there, and we need to come up to about here and start thinking about where the tread is going to go. So we're just doing the hub at the moment, so basically the tread will go in to a groove that runs around it like so, and this gives us our basic profile to work with. We can add to this in a moment, and we just do the same on the other side. Don't worry about placement because we're going to sort that out in a minute with our constraints, and we're constrained back to this point, so hovering over that point get a coincident constraint. This here we need to add a vertical constraint in, so we're going to hit escape, get the mouse pointing back and use a vertical constraint there. And we need a horizontal constraint on this one because we've missed that. And now we can look at basically getting some symmetry in here and also some equality constraints. So what I'm going to do is work around the model. So we've got this line here and this one, and they've got to be equal. But I'm also wondering if I keep this equal to. So I'm going to use all of these, click on all of these lines here, and make those equal. So if one moves in and out, we get that equality going across there if they resize. Next thing I'm going to do is take these two lines and make those equal as well. So we move those up, you can see they move together. We need to also make sure that these two have equality. And we've basically got ourselves a simple sketch here that has some mirroring across and some equality across there, so this will give us a revolve close to what we want. Next I'm going to make it symmetrical to this line, so I'm going to take these 2 points and make sure that the last line or point we select is the center point and use the symmetry constraint. Go into redundant constraints, and if we click on that redundant constraint, we can see it's that horizontal constraint there because we don't need it, and hit the delete key on the keyboard. Now got that symmetrical, so you can see how they move there. So let's start to get some constraints in. So if we pull this to the left, you can see how that's crossing over at the top. To stop that, we're going to add some length in here. So add a length. I'm going to say that one's about 3 millimeters. This length is up to you. So now when we pull this across, that doesn't cross over. Next, I'm going to set the radius or the diameter of the actual axle here. It's going to be radius because when this revolves, then this will be revolved 360 over this line. So we're going to take this point and place a height in there. I'm going to say we want a 3 millimeter hole, so I'm going to go for 1.5 millimeters, and we've got that one there. So we're starting to build up our object. We obviously need some dimensions to this. This is at the moment, it's just the wheel hub. So we can place some dimensions in here. And let's say we take the top point. I'm going to do it on this side because we've got most of our dimensioning over this side. So I'm going to take this top point, this one here, and the center point, and place a height in. And I'm going to go for 30 millimeters long there. You see how that's pulled that down, so we need to place some height in here as well. So in here, to make sure we retain the depth of this groove, let's place some height, and I'm going to go for 2 millimeters in there. So that's all set there. We can still adjust the width. Let's bring this out and over here. So I'm going to set a width. So we can use this line here and set a width. Make sure that we haven't selected another point, so select that one or another edge, and set the width to say 25 for the time being. So we've got our width there. You can see how it's beginning to constrain down. We haven't yet introduced the spreadsheet, but that's going to come in a moment. There is one more length in here that we can use to fully constrain this sketch, and that's this one here. Now, this gives some strength to this hole. So if you think the axis coming through here, then we've got this to give it some strength in here, because we're going to take out some of this spacing in here to lighten the wheel. We're going to do that later. Now, if we change in this size, then this should really change as well in relation to this. So it might be something like 2% or 3% bigger than this line here. We can do it with this constraint if I come in and name it. So we give it a name, let's say axle diameter, axle DIA, and hit OK. So we've got that one there, 1.5 millimeters. If I add a height in here, then we can use the formula. So there's a little button on the end here, which is a round button. We click on that, and now we can use the formula in here. So I'm going to start typing constraints. You see the constraints pop up here. Then we add a full stop or a dot, and then start typing your constraints. So axle DIA. And 1.5 millimeters come up. So I can use times 0.2, and then we get 0.3 millimeters. So we can do maths in here. So the other thing I need to do is actually add the constraint.axle diameter again. So plus, and I'm going to copy and paste. So you can highlight that, Control C, come in, Control V, because I'm lazy. And we've added that constraint there. If I hit OK, we get 1.8 millimeters, and OK on that, and we get our necessary length there that's been adjusted. So we've got 1.5 and 1.8, and we can just add some different values to here. So say 0.5, and hit OK, and OK that. So we've got that there. Let's close that. And we've got our profile that's starting to emerge. Now let's come over to the model and zoom in a bit. Let's revolve this. So click on the sketch, come up to the part design, and come down to the additive feature, create an additive feature and revolve. We need to select an axis. So you can see we've got the x-axis here, this one here. We need to drop down the axis and select the horizontal sketch axis or the x-axis, and we've revolved that sketch around there like so. We've still got some additional features to add to this. For instance, I may want to bring this in and have some curvature so we don't have a flat side here. But we're starting to get the idea of actually how we can create that wheel hub and then later the wheel. So let's hit OK and start to bring in our spreadsheet. So go out to do the part design, where it's got the part design, and you drop down for the workbenches, come down to the spreadsheet. We're now in the spreadsheet workbench and we've got to create a new spreadsheet, which is this icon here. Create spreadsheet or spreadsheet, create spreadsheet. We've now got our spreadsheet open and we can start looking at the constraints that we have in our sketch for this revolve. So we'll leave the spreadsheet tab there and double click on our sketch. And let's have a look, see what we've got. So looking at this, we need the axle hole, so the hole that goes through here, the diameter of that, or the radius, and we need the width and also the diameter of the hub. Let's come over to the spreadsheet and leave this open. So the first thing we want is the axle radius, because we're dealing with a profile. The other one we need is the hub radius. And then we need the hub width. And I think for the time being that will do us. So the axle radius is 1.5 mil. So just double click that and hit 1.5 and hit enter. That brings us down to the new line. Hub radius is 30 millimeters. Double click that, 30 mil. And the hub width is 25. So double click and 25 and enter. So now we've got those in there, we need to alias up these fields. So we click on the first field where it's got the value, and I'm going to use axle radius. I'm going to double click the axle radius, just hit Control C. So I'm going to copy that text in there. Make sure that field is selected. Come up to the alias, click on that and hit Control V, or just type in axle radius in there and hit enter. When I click off, this changes color and we've moved to our new field. This one's hub radius and this one's hub width. I'm just going to type those in. So now we've got these all aliased up. Just going to save it and come over to our tab that has our model in. So let's start from the axle radius. So that's this one here. This one that goes 1.5 millimeters. Double click that, use the expression button there and start typing spreadsheet. Spreadsheet comes up and start typing. The dot's already been added, so you can see that dot's already been added there. And type in axle radius and hit OK. And hit OK again. That's gone orange. Remember, we've still got the other one here, so this one is the main constraint axle diameter we've placed there. It should be axle radius actually, which is the constraint of the sketch. So that one's sitting there. We may want to change that. We've named that, but it can be used. What I'm going to do is change this to the spreadsheet one. So spreadsheet axle radius, that auto-populated there, plus spreadsheet, you can see the dot's been added, axle radius times 0.3. 1.95 centimeters, and hit OK. So that's that there. If we wanted to, we could actually add this here, this 0.3, as a spreadsheet value. So spreadsheet dot whatever you want to call that, and feed that in as well. Just going to leave that for the time being. You can see that we've got the orange going across those. Let's do this one now. So this one is the hub radius. Double click that one and do the same. So spreadsheet, click the spreadsheet, dot comes up, hub radius, okay, okay that. Let's come out to the top, let's see what we got. Oh, it's actually down the bottom, so we want the width now, so double click this one, click the button, and spreadsheet. I can press the down arrow to get to there as well, so using the down arrows on the keyboard, making sure that we got the dots in as well, so spreadsheet dot, and this one's hub, press down arrow, hub width, and press enter on there, and OK, and OK that. So those are all in there. Let's hit close. Now we've got the spreadsheet hooked up to our sketch, so I'll come into the spreadsheet and change, say, the hub radius to 30 to something like 60. Click off. You can see that's changed now. So before we go any further, what I'm going to do is rename this body. This means that when we look towards making the tire, we don't get these bodies confused, which it can be very easily when we're using multi-body modeling. To rename the body, it's quite easy. So click on the body, right click and rename. You can see we've got it flashing there, and just change this to hub. That's all renamed, and we're ready to go on to our next part. Now comes to testing it. If we change this slightly, so let's change this to 2 and say this one to 35 and click off, you can see it's worked quite well. It's actually started moving. The problem comes when we change this quite dramatically. So let's change this hub to say to 80 and click off. You can see it's gone into error. And if we come back to the model and double click the sketch, you can see that we've got some deform constraints in here because we've changed this too much at one time. To get over this, we can use, instead of equality constraints, we can actually use some proper heights in here. So we've got height here, and we can see that equality hasn't really worked with this one. So if you're going to change this as I've done it, then we need to add some more constraints to stop that from happening. So for instance, we can see this one has been pushed up here, and all of these haven't come along with it. Let's have a look how we can resolve this. So what I'm going to do is hit close, come up to edit, undo. We can see the sketch has got a tick by it. We can hit Control R. Let's go edit, undo again, and Control Z. Go hitting Control Z. Got a tick by the spreadsheet. Let's hit Control R and keep going. There we go. So we're back to where we was. Look at the spreadsheet. We've got 25, 30, 1.5. Let's have a look at the sketch. And we saw that this went. So I'm going to take the equality out of here. This one here. Just delete that. And I'm going to keep these two in line. So taking these 2 points and placing them in line. Because we got this constraint here. 1.95 constraint. And hopefully that should keep in line. So let's close that and test it. Just going to save it. Go into the spreadsheet and change the hub radius to say 80 and hit enter. We're looking good. Come over, we can see that's changed quite nicely. Let's go 130. Let's go 230. 230, hit enter. We're all fine. And let's bring this down to 30. So we're changing, and that's changing nicely. We can see we've got some deformation again. So let's see what that is. So we can see that's kept in line absolutely fine, but we've got problems now with this bottom one. So you can see certain constraints are okay for using spreadsheets, other get deformed with larger changes if you're going from 80 to 280, etc. So I just can come over and undo this a couple of times. Actually, let's go back to the original. So close all, close without saving, file, recent. This is the reason why you save. And double click that sketch. Let's see what we've got. So we've got that constraint in there. We've got the height constraint, which I'm going to do the same. So I'm going to take this point, and though it's fully constrained, if I put a vertical constraint in there, it's saying 36, so I can't actually do that. So what I need to do is remove some of these constraints. So we've got the equality constraint here. Let's delete that and make sure that these two are in line. Place those in line. Saying 33 is a problem. So why is that? I can move this up and down. These are in line. So we've got an equality here. What's this equality to? To this one here, down here. Let's delete that, get rid of that. And we've got equality going across these two. That's the one that's causing an issue. Let's make sure that one's not selected. Select this constraint and delete it. And what we'll do is that can move up and down now. And we'll place these 2 points in line. For horizontal constraint. And let's have a look, see what else we got. So it's not fully constrained yet. This can move up and down. And we've got lateral movement as well. So we need to use these constraints against these points. And the height constraint against these points as well. Let's bring that back up. Well, we know that these two were equal. So I'm going to name this one groove height. It's been used in different places. We could have changed this 3mm and actually place it here, but we'll use that against that one. Doesn't really matter. So let's place a height in this one and use the formula. And we need constraints. Type in constraints dot groove height, and 3mm come in there. Hit OK, and OK that one. So that's pulling the constraint straight from this document, this sketch. Now we've got that one. We've got this one in line, so this one doesn't go up and down, but we've got some width to deal with here as well. Let's set these to be the same, because we can't use the equality because it gets damaged when we change it in our sketch. So that's come into this, and again use constraints dot groove height, and OK that. And we do the same for this one, these two. Constraint dot groove height. Now we can take this point and make them symmetrical to this line. Now we've got redundant constraint 30, so I click on that one and hit delete. And that's all constrained down now. Now I'm looking around and thinking, do I need this constraint here if we're using symmetry constraints to solve that issue? Because I've got two of them on here, so if I delete this one and use this point, and this one will become redundant, and use this vertical line and use symmetry, click on the redundant constraint 28 and hit delete. That gets rid of that constraint. So that's good. Let's test that. Let's close that. I'm going to save. I'm going to bring the spreadsheet back. And let's have a look. We've got 1.5. Let's change the hub radius height to something like 80. It's not gone into any problems, so let's go 200. It's looking good. So now we've got that, and that's looking quite good. So let's select the spreadsheet again, and let's go for the axle 50. That one there, and the width 100, and it looks like it's working. So that's looking all good now. And let's double click that sketch and have a look, see what's happened. And yeah, so that's all working well. We've pushed it to the streams. We wouldn't actually go that size because we would have to think about these edges as well and keep those in proportion as well. So let's bring this back down to 2 radius of 30 and a width of 20. That's 25. Let's go 20. And there we go. So that's working pretty well now. So what I'm going to do now is I'm going to add some detail to this, but before I add the detail, we're going to need to work on the tire. So we're going to build the tire around here. Now this is going to be done in another body, and we're going to reference this hub. So we're going to reference the geometry in the hub. The reason being is that we may want to print this in something like ABS, and then we use a flexible print medium for the tire. So we have that option to be able to export out the individual elements, so the hub and the tire. So let's have a look at the tire now. So our next job is to create another body for the tire itself. We're going to be using a multi-body workflow. For that, I'm going to come over to the part design. In the part design, and we can see at the moment that the hub is highlighted. So this is highlighted in bold, and that means it's the active body. If I added a sketch now, it will be actually added to this body. We need to create a new body. So click on the icon here, I'll come over to the task and create a body. Go out to the model, we can see that body's been created and it's become active. So anything I do will be placed in this body, and that's important when we come to multi-body modeling. It's quite easy to get these mixed up. So what I want to do is create a sketch, and I want to come in and reference the original sketch to this revolve. If I come into the hub and come into the revolve and just click on this sketch and press the spacebar, we can see that sketch there. Let's hide the revolution. Click on the revolution, press the spacebar, and we've got this shape that we've created the revolution from. I want to take this edge and use it as a reference. I can't reference this as it stands at the moment because it's in another body. So this is our active body. It's in bold. If it's not in bold and this was our active body, we just click on body 001, right click and toggle active body. Actually, while we're here, let's rename this to tire. So let's create a sketch and show what actually happens. So we've got our body here, we create a sketch and we're going to place it along the XY plane. And what I want to do is trace, well, sketch a tire, but trace this part. So let's try to pull in this geometry. If I try to pull it in, you see we get a stop sign come up, and it's down the bottom. You can see the object belongs to another body, can't link. How do we resolve this? Well, let's close. You can see our sketch is there. We're going to leave that there. The tire is active. That's important because we're going to be using this tool here, the subshape binder. What this does is create a link from one body to another, or one body to itself, a geometry in its own body to itself. To do that, we've got to have the active body, and this is the body that's not active that we're going to create a link from, and it's this sketch, this one here. We can either select, say, the edges or the whole sketch itself. I'm going to control select the edges. So I'm going to control select all of these. I'm going to bring these in. Click on the subshape binder or come up to part design, create subshape binder. Binder's been brought in and placed here. If I hide this sketch now, pressing the spacebar, we get that edge. It's important to hide it because if we try to reference this edge, then it comes up the same error because it may be that that sketch is laying on top of this geometry. Let's come into the sketch and start pulling in this as reference. We can see how that sketch has been laid there on top of that, and use the external geometry tool. I'm going to come in and bring in these points, and you can see we've got no problems in bringing in geometry from this. So we've got those points there. Now we're going to start creating the tyre. For that, I'm going to use a polyline, and it may be worth thinking about tolerances here when you're creating this tyre, because it's got to fit on top of this one, and if we trace this line exactly, then we may get into problems. What we need to do is add a bit of tolerance in here, say coming out here and pulling this line all the way down and across. Hit escape, escape again, and then we use some height between these two and placing our tolerances, so 0.25 millimeters, like so, making sure that these two are in line, and these two, let's set a length of 0.25, and making sure that this point and this point are in line, and this one are in line. Trying to keep away from the equality because, as you saw, changing the sketch size through the spreadsheet has a tendency to rip that apart. And last of all, height between these two of 0.25. So got those in there. We've got actually some length in here as well that we need to sort out. So let's take these two and set a length 0.25. So we've got a bit of tolerance there, and we can start sketching. So I want to place a curve up here and connect it up to these points. So let's place the arc in. So we're going to place an arc for the top, and then I'm going to use straight lines from this point down to this point in here. So auto connected to there, auto constrained to there, and we'll do the same with this one as well. To come in and point on object constraint there. I've actually missed that one, so I'm going to use this point and this point, and a point or coincident constraint there. Make sure that this point, which controls this arc, so it moves side to side, so this point can go on this line with a point on object constraint. So those are in there. We don't have to worry about symmetry because we can move this up and down, and we can decide what this is going to look like. I may keep these in lines, so I'm going to take this point and place those in line. And we get redundant constraint, which is number 23. Let's delete that. So that's in line there. That moves up and down. This one we've got a problem with, so we'll place that one in line as well. That's better. So we've got all those in line. And now we need to set the height. So think what we've got, well, we can set the height here, but we want to get the height from, say, here, which is the top of our hub, to here. So a way of doing that is to use tangency with some construction geometry. So I'm going to place a line, goes across here. Make this construction geometry by using the sketch geometries and toggle construction geometry, or use the toolbar, this icon here, and then take this arc and this line and create them tangent to each other. So we've got this line here that moves up and down. Let's lock this line down by taking this point and this point here and setting a height. I'm going to set that one to 20 millimeters. We're going to be using that in our spreadsheet. And we've basically got this free running. So I'm going to take this point and this line and just do a point on line constraint there. And this doesn't really matter, but let's place it in line somewhere. So let's take this one and place them in line so it's constrained down. This is fully constrained now. Let's hit close. We've now created the top of our tire, and if we revolve this using part design, making sure the sketch is selected, part design, ground additive feature and revolve, or use the toolbar, the moment is disappearing. So we need to select an axis. Now the axis we want to select runs this way. So it should be the horizontal sketch axis. So we've got that one there. And we've created our tire. We may want to make some adjustments to make this easier to fit on. But let's hit OK. And we have our tire now. And let's bring back our revolution. And we'll see how that fits in there. So that's fitting in there nicely. At the moment, the revolution tire diameter, well, the tire wall diameter, you can see that in there, which is 20 millimeters. So this is the height from there to the hub, is fixed. If we change the spreadsheet, let's go into the spreadsheet, and that's something like 130 on here. Nothing's broken, and you can see that's moved with it. But we may want to add this tire to the spreadsheet as well. Let's come into the spreadsheet and just change this back. Let's come into the spreadsheet and set a tire height of something like 10 millimeters. Make sure that we set the alias. Hit enter, so that's colored now. We come into our model, come down to revolution, come down to the sketch, double click the sketch, and we'll double click this height. We can see we've got a problem. We can see the tangency hasn't worked. So when using the spreadsheet, we have to be careful of that as well. So let's get rid of that tangency. So there's a couple of methods I've just tried. One of them was to place a point on here, like so, and use that against this point with a height. That didn't seem to work because that point got separated. The only way that I can think of doing this, let's get rid of that, is basically use this point with this point here and placing a height in there. So that's 30 millimeters at the moment. So we've got 30 millimeters. That's fairly constrained, but we need to control that by the spreadsheet. And also we've got to take into account this. So I'm going to change this one to be a diameter. So come in, change that to be diameter. Well, let's change it to be a radius actually. So we've got a radius at the moment of 12 mil. Okay, that. You can see it's invalid because we've gone into redundant constraint. And that's because we've got these in lines. So I'm going to remove these inline constraints. So this is the whole thing with this. Sometimes you have to place some constraints in, try them, and just try something else to see if we can get around certain problems. So we've moved that inline constraint, so these move now. I'm going to set a radius on here. So we'll set the radius of 12 mil. So that's there. And now let's place these back in line, like so, because we don't want this to be in line with this one, which these two were, because it would cause us the problem. So now we can take that radius and use it in the equation for this one. So we know we've got a -12 off of this height. So let's close that and come into our spreadsheet. So our tyre height is at the moment 10. So what we need to do is come into this sketch, have a look at this constraint, and set this to spreadsheet dot tyre height, and then minus the 12, and hit OK. Hit OK on that. Therefore, we've got the radius here of 12, and this has been placed further down, so we've got to be careful of that. So let's come into our spreadsheet now and set this to something like 15. Let's go back, got that there, it all looks good. Let's go back into the sketch and have a look, see what's happened. So that's sitting in there. So we've got the 2 millimeters because we set it to, 3 millimeters because we set it to 15, and 12 millimeters there. So that makes 15 height. For completeness, what we can do is come into this one and let's name this. So this is going to be tread radius. I'm just going to call it tread rad. Okay, that. And let's double click this one. So click on the formula. We've got 12 in here. Now we're going to replace it with this radius. The problem being is that we're going to go into a unit mismatch here. And I'll show you what that is in a minute and how to fix it. So we've got this minus in here. If we type in constraints dot tread rad for tread rad, you can see we've got the problem here, unit mismatch. To fix this, we use a times 1.0 millimeters. Then we use the caret symbol, this one here, and type in -1. Therefore, we get the result. Hit OK, hit OK again, and that's all set. So now if we close that and use our spreadsheet again, let's zoom out a bit so we can see what we're doing, and use the spreadsheet again and change the tyre height, say 20. When we go back into this sketch, and this should have been changed, so that looks like it's changed. Now look at the sketch, we could see we got 8 in there and the 12, which makes our 20. So this should be good to go. So if we come in and test this, so this time I can come into the spreadsheet and be quite extreme with this. So hub radius, let's go for 100 there, and tyre height 200, and axle radius about 50. That's quite extreme, and we get that working quite well there. And if we look at the sketch, we shouldn't see anything that's deformed in here. So we've got that up there, which is good, and that's all good there. Let's close that and set this back. So come into the spreadsheet, axle radius, let's say 2, hub radius of 20, hub width we can keep, tyre height of 15. And we're back to normal now. And let's double click our sketch. So let's come in here and you can see that sketch is all working absolutely fine. So we just have to watch out for certain constraints because they can be ripped apart with a spreadsheet. It seems like the constraints that are more fixed, such as inline constraints, symmetry constraints, data constraints, so these are called data constraints where you place data in there, are the more stable to use in sketches. Let's close out of here and I'm just going to hit save. Control S to save. So we've got our basic spreadsheet up and running. We can now add some detailing in here. So we've got a nice planner face here, so I can add some detailing in here by attaching the sketch to it. Best to attach the sketch on one of the base planes because I might change this in a minute. But the next thing we're going to do is remove material from here to make this a bit lighter. So to lighten this wheel, I'm going to come in and create a sketch and remove some material in here. I'm also going to take the original sketch of the hub, so this one here, I'm going to come in and double click that sketch and I'm going to add a rectangle in here. So I'm using the rectangle tool and create a rectangle in here. This will become a void then. So I can take these 2 points and keep them in line, the same as these 2 points. And I'm going to do the same here. And really what I should have done is selected the horizontal constraint and click one, click the other. Those are in line now. We don't need to set any height here because this is dealt with. And you can see we've got 3mm there, and we've got a height of 2mm coming in here, and this 2.6, which is a calculated distance in here. I may use the same for over here, so I may reference this one. And you can see the formula in here. May reference that over to the other side, over here. This formula, by the way, we've got this maths in here. But obviously we can get rid of one of these and use times 1.3 to keep it the same. So we can take that out. Instead of 0.3, let's put 1.3. And that will still equal the 2.6mm there. There we go, 2.6mm. I just added that in there to show you can do plus, minus, etc. So we need to set this height. Let's give this a name, 2.6mm, and name this to axle. It's the second diameter. I'm not sure what to call this. I'm just going to go sec dia and OK that, and we'll place a height in here, and that's going to be the constraints dot axle sec dia, and OK that. So that becomes a void. If I close that and hover over that revolution, you can see that there's a void inside there now. Let's hide that tread there and hover over this revolution, you can see the void inside there. So that's a bit of weight saving already we've done in there. Next bit we're going to do is add some holes that run through here to take the weight off of here. To add holes to this hub or spaces that allow this to be resized and also sized with it, we're going to be using some tangency in there. First thing I must make sure is that the hub is the active body, because we have two bodies in here. We've got the hub here and the tire. We can select the active body by right clicking and toggle active body. So this tire is active at the moment. If I created a sketch, now it will be added to this tire body, which I don't want. So I want to add it to the hub. So I can double click that as well, and that makes it active as well. So you can see if I click off, that hub is in bold. Make sure nothing's selected because we want to place the sketch along the base axis, because we may change this face. Instead of making it planar, I may make it curved in here to add a bit more detail. Let's get ourselves positioned. So I want it on along the, let's bring this around this way so we can see, make sure that's upright. Let's click right. We want it along the YZ axis. So make sure nothing's selected, create a sketch, and along the YZ axis. You can see that one there. Hit OK. What's happened is place the sketch in the middle of this shape. To move it, come over to the model and come down to that sketch. So you'll see it's not in the revolution, it's in the hub, and it's this sketch 02 there. Come down to data, and if we look down, it's attached to the YZ plane, it's map mode, it's flat face, so the attachment will be the one that you want to move. If we look at the sketch, we've got the red and the green, so the red is the X and the green is the Y. Z is normal to sketch this way. It differs from our global coordinate system. So these are the sketch axis, not the global coordinate system. Come down to the attachment, come down to the position and change the Z. And we're going to move this out this way. We only need to sketch on one side because we're going to be going through all on that pocket. Now that's positioned, let's come around to the right and start sketching. I'm going to pull in some geometry. So I'm going to pull in these top and this ring, so these two circles. The reason is I'm going to create circles in here that touch them. I may leave this one as it is, I may not need this ring, and what will happen is that will be used as construction geometry for the spacing. So come in and use the external geometry and pull in the top one first. And we can start creating some circles in here. So the first circle, I'm going to actually place it across this vertical axis, like so. Now I've got the auto constraints on, so I come over to the task, you can see I've got the auto constraints on. If I come up and touch this edge, they will be tangent to that. And let's create another one and place it tangent to that edge. I'm going to create about 4 in here. Now let's go 5. So that one, another one tangent to that edge, and one more. And if you don't go tangent to the edge, then we'll just add the tangency in a minute. I'm going to hit escape. I'm going to do more tangencies across here. So I'm going to use the tangency tool. And I'm going to click the tangency tool. I'm not going to click any of these circles. I'm just going to click the tangency tool. So that's active now. And I've got to do this one and make that tangent to there. Now I'm going to make them tangent to each other. So I'm going to take this circle, tangent to this one, and I'm going to work my way around and make them tangent to each other, like so. Now, I'm not going to add tangency to these two. I'm going to hit escape. And the reason being, I'm going to pull this out so they're by each other like this, and do the same this side. Because what will happen, they sometimes can cause the tangency to flip to the other side if they cross over. So make sure they're not crossed first. And make sure nothing's selected. Click the tangency tool and do tangency against those two and tangency against these two. Those are all tangent to each other. One other thing I've got to do, one other constraint, is take them all and we're going to make them equal. So use the equality against there. Those are all fully constrained. See what's happened? They're all sitting there fully constrained and it's taking up space. I'm now going to select all of them and make them construction. So using the construction geometry there, they will turn a light blue because they're fully constrained construction geometry. I'm now going to add the holes. See these points? How they're spaced evenly? This is perfect, so I can add the holes in here, like so. Auto constrain into those points. So this is just a basic removal of material with holes. You may want to do something a bit more interesting in here, and we can get to that in enough time. I just hit escape and I'm going to select all of these circles and make them equal. or I can just come in once they're all selected and add a diameter across there. So they will have the equality against them, so you can see those two are equal and all the rest are, and also a diameter. Let's set the diameter to 10, and actually may reference this in our spreadsheet, so we'll do that in a minute. Let's hit OK and hit close. So we've got those sitting on there, so they're sitting away, that's fine. What we need to do now is select that sketch and select the pocket or part design. This is a subtractive feature because we're taking material away, and pocket. They disappear because it's gone into error, and that's all because we've got the length of 5mm. If this was increased, it will actually start to pocket in here. But we just need to select through all. That will take that and pass it through this hub out the other side. Now we may need to reduce the size of this because it's taking a chunk out the top. So let's hit OK and let's come into the spreadsheet and set that up. So this is void diameter, or whatever you want to call that, and we'll set that to 8. Let's come into the pocket, open that up and look at the sketch and double click that sketch. That's set the diameter, so somewhere in here is the diameter, so this one here, and use the formula. We're looking at spreadsheet, dots already been added, and this is void radius. And we haven't set that up yet. We haven't actually added the alias to that. So let's cancel that and add an alias to this. So the void diameter, and we add this as void dia. Make sure you hit enter, otherwise that won't take. Let's come back in, double click that, and spreadsheet, dots already been added, void, remember it's case sensitive, so it's capital V, capital D, void dia. Okay, okay that, and close. Now we've got the voids in there, reducing the weight. Let's come into the tire and bring back the revolution, so the last action in there, and we can see that all together. And save that, and this is ready for 3D printing. So we've got two bodies in here that we can export out. So we've got the hub, file, export, and you can see it comes up the name of the project and which one you've picked. So I've picked the hub there, I've just picked the body, save that, and I can pick the tire, file, export, it says tire there, and save that. Or I can select both of them, control click both of them, hold down the control, file, export, and it's named it the project, and save that. You may want to play with this tire, the way this is attached to here. It all depends on your preference, the material you're using, etc., how much flexibility you have in the material. That's down to you. I'm going to create a new document and just import those in. So let's file import and let's see what we have, how they've exported out. And we've got all those three there. I'm just going to hold down Shift and select all three of those and open. And that'll pull in all three. So it's placed them on top of each other. We can see we've got all the individual ones there. Let's highlight them all and press the space bar. This is both of them. So that one there. This is just the tire. And this one is just the hub. So that's a quick, we'll say quick, was there for quite a long time, but we went through all the different scenarios there, the problems that you may encounter, etc. But that's how you would set up a spreadsheet that controlled the hub and tire for 3D printing, something for like an RC plane or even a car, etc. It's the same process for any of those. So I hope you enjoyed that video, and I hope to see you again soon. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a Ko-Fi site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.